be talking about debris flows. The first thing I'll be talking about is your slope gradient. Imagine this is your slope here. Up here is your source area. It is a very steep angle, about 26 to 45 degrees. Down here is your area of deposition. It's less than 5 degrees in steepness. Why is this? It is because of physics. You have your rock on your slope. You have a gravity vector that goes directly downward. This vector can be divided into two separate vectors, your normal vector, which goes perpendicular to your slope, and your shear stress vector, which goes down your slope, and opposes your shear strength vector, which goes up your slope. At lower angles, your shear stress vector is much smaller than your shear strength vector. As the angle increases, though, your shear strength will stay the same while your shear stress increases. Eventually, this vector will be enough longer than this vector that your rock will just start going. Now, this part down here has to be so shallow of an angle because you've built up momentum from all of your flow just going down your hill. And so it has to get a very flat angle in order to slow down your momentum enough to just stop. The next thing I want to talk to you about is water. Water is often involved in debris flows in that you have your soil here. If your soil gets very saturated, the water will get in between all of your grains and it will start just pushing them apart, which destabilizes your soil. It makes them much less cohesive. Additionally, if this is happening during a freeze-thaw or potential for a freeze-thaw cycle, the water getting in between will start wedging apart your grains, if this is a rock, for example. And this will make your slope a lot less stable as well, as your rock suddenly has all these cracks in it. And yes, that is debris flows.